This conference will now be recorded.
Good evening. We are expecting some more participants, so we would like to wait for another 2 to 3 minutes. Thank you.
This conference will now be recorded.
Yes, good evening. We are back in C programming session. So I would like to know if you have any doubts with respect to last session. Um, you can have any doubts, you can ask any doubts starting from um, if your name starts from A, sequentially you can ask Abhi. If you have any doubts, you can ask. Okay, Balaji.
No, nothing. No, nothing.
Okay. Kirti. Nitin. Okay. If any of you are new to today's session, new to the C programming on with this course on today only, then I'm requesting you to hear previous sessions audio, which is available in the YouTube link. So, now in the last session, we have seen what is the purpose of programming, what is the differences of low-level programming and high-level programming. And I should appreciate one of our participant, since due to his good question of saying that he was believing that C programming is only for doing the mathematical operations. This question has triggered me to take the lecture in a different manner, which I didn't also expect to go in that direction. So that question has helped us to explore little bit of programming in a different perspective, since basically C programming, any textbooks or any classrooms which I have come across also does not brief with respect to the hardware architecture, taking examples as ALU or so. So thanks to that participant who has asked the question, you who was believing that C programming language is for doing only mathematical computation. So today we will have a look on the basic building blocks like constants and variables. The constants are nothing but the values which cannot be changed, and variable are nothing but parameters which can be changed. That is, there are certain rules for constants or variable. Basically, this you would have observed, but as a matter of lecture, we need to specify in a brief way that you already know that integers, for example, must must be a single digit at least, and it will not contain any decimal point. And integer can be a zero, or otherwise it can be a positive value or a negative value. Okay, this is the basic thing for an integer, while float values nothing but, or real values are nothing but with the decimal digits. It should have some decimal digits, and it too can handle positive values or negative value on zero. And with respect to any with respect to compilers, the integer values and float value limits can change. For turbo and all, that the values uh, ranges from minus 327,682 plus 327,67. If you want, you can make a note of it. I'll repeat. For integers, the value range between minus 32768 to plus 32767. To extend this limit, we will use a long keyword before for integer values, where we can extend this limit. That is, basically turbo Z's are framed to handle the values with 8-bit operations. That is, the the limits between the, for example, I'll share you a value here. For example, 8-bit memory means it is the values are represented like this, isn't it? And so these 8 bits values can handle, for when we convert it into decimal, it can handle between minus 327,682 plus 32767. Okay, we are not going to go in depth into how this representation of minus is handled in the memory or plus is handled in the memory, how to convert the 8-bit data into decimal and all. Okay, and similarly we have a limit for real also. I request you to check internet to know these details. And exponentials can also be handled. Exponentials will not For exponentials can also be handled where we have two parameters for representing exponentials. Say for example, the exponentials values, say something like 2.0 E57. Okay, uh, this is this is how we represent. While exponential in our mathematical representation, we do it as we do it as 2.0 into 10 to the power of 5 6. Okay. While in coming to representing in language, we represent like this. While how to employ this and all, if we how to use it or how to do computation using these values and all, if we come across any examples in future, we will discuss on it in detail. Okay. And there is also range for exponential representation. The range is minus 3.4 E38 to plus 3.4 E38. This is the range for representation. While this portion is called as mantissa part, that is before E, and after E is called as exponential part. Okay. And then uh, we have character constants, and character constants are also being allowed in the to take as a to represent as a value. While representing, we will be using representing like with an apostrophe before that, and then character. Okay. We will be seeing shortly how we'll be using in the compilers. And so next is variable. Variable is a is it also holds a value, while these values can change. Okay. And we'll now go for we'll see how to install the compiler. So we will download the compiler now. So basically, how a language has to be approached is similar to our vocabulary language, our linguistic language. Only it has to be approached, and so we don't ask for any questions like why A to Z. It can be Z to A. So we learned with the grammar that which we cannot question. While we have to employ the usage of grammar, since it is all framed into the architecture of any language. So similarly here we have set of rules which we have to handle it compulsorily. So the so that the compiler can also understand what we are instructing it to it. The compiler repeatedly, which I mean here is that is the compiler is nothing but a C compiler is nothing but is itself a program which can understand the C language, that is understand our programming. Okay. So default I got some programs, so I'm closing using this tab here on the left top while I'm maintaining this allow program alone. So expanding it, so we got the program. Default it is available in the compiler. So we have already discussed last time that any program will have to start with the main function, since the compiler needs to understand from where it has to start the computations. Since everything is in background, we have seen that it is nothing but a computation finally. And so it has to, there should be some starting point from where we can move forward. That start point is mentioned as main function, and so always main, the one of the only one, if a program contains only one function, then it should be main function only. So the function is represented with two. Are you able to see my screen on the window? Anyone can respond.
Yes.
Hello. Yes, thank you. Um, and so we have the parenthesis, and so main function is accompanied with the two parentheses, open and close parenthesis. That means that is it is a function. When there is a name followed by a parenthesis, it means a function, and more than that, it is being accompanied with curly braces. If you see here, curly braces are available here, the left extreme corners. So any function should have this type of format. I'll I'll show it in the notepad also. So any function should have this framework. So whatever the program which we need to execute will be within this. That is mainly the program in the sense the computations which we require, the process we require, or otherwise the algorithm which we need to implement will be within this curly. We have to start from here and move forward within the curly braces. And any function should return some value. Return in the sense, after doing some computations, there will be some data which we need to hand over. That is, this main person has done some job, and so he has to give back some finished product, isn't it? Or otherwise, he has to hand over some finished good, or otherwise finished computed value to the previous person whoever has asked. And so what is that value we are expecting here? We have to mention. Usually we should return with some some value. Okay, it cannot be void of anything. That is the ANSI standard. ANSI standard is a standard which has been framed by the some, we can say, some society. Okay, though for they have maintained some standards so that it will be common to all across the world. So when we need to return, if in our previous program, since in the allowable program there is nothing to return, and so if we are using an int before main, then we have to return 0. Okay, this is a standard format, though in the program compiler this turbo c accepts void, and so we are able to compile with void also. Void means there is nothing. The the person who is calling the main function, who is calling compiler, is calling the main function, and so he will be instructed previously also, that he will be instructed that we are not returning anything to you after computing the procedures in the main function. And so let us come back to the uh, Okay. uh, Here we can find one more function. We will remove these things. We will get clear about this later. So these are all predefined functions. So main function is known to the compiler, and so it will default call the main function. While we are having a one more function, printf, opened again within braces with double apostrophe, and then that is punctuation marks. Okay, hello world, and we are closing it, and then we are closing the punctuations, or again parentheses are closed, and then we have a colon, semicolon. So this is one statement program. That is, this is one statement within the C program. This is one instructions we are giving as a one statement, and so a program should be the here C program will be sequentially computed, and so the statements has to be fed sequentially. So whatever we want to compute, we have to write program in a sequential way, and every statement should be ending with a semicolon. The compiler reads that when a semicolon it finds a semicolon, then it takes that one statement is given to it. And so whenever a semicolon is given, it consider it to be in one statement. Suppose if we are keeping a semicolon here, then it will stop up to printf. Since it is not the proper format of mentioning a printf function, then it will throw us with a compiler error. And this printf is a predefined function. That is, what printf in background it has to be defined. That is, the intricacies of printf, how it has to handle the background is already defined by the compiler itself, and so we need not write any program to display hello world. When we need to display hello world by ourselves, we need to run a sequence of computations background. That is, we need to handle that hello world character completely and to display. That is, it needs to speak with the video driver graphics cards or video driver chips, and so that communications are handled by this single printf function, and this is a predefined function which is already available in the C compiler. And so where it is available, we need to include in this program. That is, that set of function is already predefined, but that means it has to be included in this program. It doesn't mean that since it can be, we need not include that. What I mean to say is, we are avoiding to write the uh, operations required for printf. That is, we need to print it on the screen, means we have to write a set of instructions to the compiler. So to avoid that, we are already given with that pre-built function, and so we need to include that function explanations intricately in this program also. And so where it is located in a header. Header is nothing but a start point. We can say start. It's like a dictionary or something like that, where it is these details are already available. That is what printf should function. So this is available as a standard input output .h. This is an header file, and so we have to include this file in this program. And so the format for including it in the program is as hash include stdio dot h, and we have to close it. Okay, so we need to include, since this is defined already. I request that you don't corrupt these header files which are available in the C turbo C installations. Okay, So how to run this program? Before running the program, we need to compile for the error checks. So we are running through compiler tab on the top, and we have seen, since it's a simple statement, one statement we are running, so we will not have any problem. So it is done. So if you want, you can make a file. If there are multiple files and we are computing it, then we need to make it, and then we are running it now. Alternatively, you can use alt tab also. Alt plus, when after pressing alt and then this highlighted with red color, R. So when you press that, we'll be giving it run command. Run, we can, for shortcut we can use control plus 9, or otherwise you can use the arrow key and press run. Okay, since now we will not be able to see the program, it has displayed and went off. Why? It has, in a short span it has displayed and it has went off. So to see that, we need to halt the program for some time. Okay, so to halt the program for some time, we need to write a command get ch function. This function will halt the program. This is also an inbuilt function, and so this function is available in an header file on io.h. So I'm pressing alt C to compile it, then alt R. So we are able to see, you see, already we run the program once. This is second time we are run. So the previous run, hello world, is also available on the screen, and current hello world is also displayed. Are you able to see this screen? Anyone, please?
Yes.
Okay, thank you. You can, if you press any key, it will come out of that screen. And since you have seen that the hello world, the two times we are run, but it has got appended along in the same line. If you need to put it, if you need to show that hello world in a new line, then we can add a new line. This indicates that we want the compiler to include a line after displaying it hello world. And so again I'll compile it and run the program. 1 minute. Yes. Okay. We have to save before running it, compiling it. Okay. And so this we can include anywhere. This is a new line indication to the program. Wherever we need to include a new line, we can add. It can be added in front, but whatever we want to display, it should be written between these double quotes. So we can include before allow also a new line. It's up to us. And if we need to clear the screen, there is an inbuilt function, since all our previous executions are also available in the screen. So if we need to have a fresh screen for every run, then we can run this function. So every statement should be ending with a semicolon. So again, So hello world. You see previous screen is now cleared. So this is a sample program. So do you have any doubts with this? If you have any doubts, if you want me to explain any topic in this, any point in this program,
No, no.
okay. So we will go for our one more topic, that is the basic explanations we will give that here. We will have basically these are all nothing but instructions which we are giving, and so we have to declare certain things when basically it is used for computations, and so we'll mostly handle with values, and so we need to declare for any variable which we are using it with type declaration, that is what type of variable we are going to use in the program, we need to declare it. For example, if we are going to use a value variable, that is we need to plan our program. Okay, any program needs to be planned. Suppose we have a calculation, say something like if we need to calculate length of a line or otherwise area of a circle or area of a square, what are the values we require for calculating the area? We requiring for area we require only one value, that is the side, and so we will be doing, we need to do a computation on that. Okay. Um, shall we take square itself? We'll take a square program, uh, since it will be handling with only single value. So we will be taking type, we have to do a type declaration for that. That is, since it has only one value which we need to as an input, we need only one value. Okay. While for indicating that value the output we require one more variable, that is we can say it as a side comma area. So we need two values. The two values, since I am going to consider it to be a integer number for my requirement, we am going to use it as an integer number only currently. And so the first value is side, and the output of that area I'm maintaining it as an area. These two are I'm mentioning it as an integer. Okay. And so next instruction we will be having arithmetics over that. So those are arithmetic instructions. So we need to initialize any value. We can't leave it without initialization. Since any memory, this is nothing but a memory handling. Okay. Now we are handling with the two variables. So this will take one memory. This will take one memory. And so memory allocations and all we will be seeing it. Usually for a C, this type of compilers, turbo compilers, this one very integer variables will take 2 bytes of memory. Side will take 2 bytes, area will take 2 bytes. So we have to be very careful in the outcome of multiplications and all. When we use huge numbers, for example, we have seen other time the limits of the limits as of a range of the upper limit as 3 to 7. Can anyone tell what was the upper limit of an integer? 3 to 7? 6, 7. Okay, if we are multiplying again with one more 3 to 7, 6, 7, the output is more than the 5-digit number. And so maintaining it an integer with 2-byte digit, 2-byte value, 2-byte memory is difficult. And so in that case, we need to extend the memory for these variables. And so in that case, we'll be using one more definition as long, where here long means we'll be the memory allocation for side and area will be 32 bit, that is 4 bytes. While in our case, we'll be seeing it as integer now. And so we need to initialize it. And so instead of taking the input directly from the keyboard, we will be initializing it locally within the program itself. To initialize, we can use the equal to operator, and then on the right side we can have it as value. And so value is a this is a 4 is a constant, and so now this is an integer value, and we are assigning it to the variable side, isn't it? So we'll take this program itself, we'll directly go to the C program. There itself we will be seeing whether the compiler accepts this type of computations or not also. So we'll close this program, we'll take up a new program, name it as square.cpp. So you can expand this window by using the right top arrow buttons. So by default we require standard io.h is minimum required, since it's compulsory to include. So here also I'll be using void, though it. So always we can have clear differences, that is curly braces open and closed should be clearly visible. And so it's better to take a tab space for, or otherwise we can leave some 2-3 spaces from the edge of the window. So edge of the that respective functions curly braces. To be very precise, we have to get into that function braces with at least 2 tabs. One tab is minimum required, otherwise at least 2 spaces we can leave it and then proceed, so that our open braces and closed braces are we can match easily. Here you can see this is open and close, and so we can easily match across these two. So now I will initialize the integer value, integer side comma area colon. I can initialize here also after defining definition also I can initialize. And so area is equal to side into side. So we can print this data on the screen. Whatever we want to print on the screen, we can print it like that. we have to type it here, and then whatever the value we need to include following this. If in any computed values or variable, we need to include, see, in continuity to the strings, which this is string, we can tell area of the square, and we have to call that variable within that quotes. Okay, and so we will be using a special character, that is percentage symbol, and since we have used an integer, we are using here d. Okay, decimal value, and so sorry, not decimal, we have to use a d here, and we have to close the parenthesis. Since this is a integer value, we are mentioning that this is in this place a integer comes here at this location. But what is that integer? And so to mention that, we have to mention out of that quotes, and so we are saying it as area, comma, area, and then close the parenthesis, end the statement, and now we are going to run the program. We'll see what are the faults. There is no fault as of now, so we'll run the program. So we are not able to see the data since get character is not mentioned. So we need to include the respective file, header file. So area of the square is 4. So if we need to include a new line for every run, we can do. So we can make it as a standard practice. These are all standard practice of maintaining the clear visibility of open and close parentheses for any function, and then the clear screen, and then get characters, if at all, if there is any keyboard interactions. Okay. Do you have any doubts with this? And so in this we have seen the declaration instruction, and then the arithmetic instructions here, and then there is control instructions also. That is when we need to control the sequence of the program. That is when we need to come out, when we can say that if we are available with certain things, then we will compute in a certain fashion. If it are not available with certain things, we will compute in a different fashion. That is decision making. So those things we will be seeing shortly as the classes proceed. And uh, I would like to introduce one more function, inbuilt function here. Instead of saying side into side, we have an inbuilt function, power. Is an inbuilt function, that is power a over b. We can say this as, we can consider this as a, if we consider this as b, and so a over b. While this function is explained in one more file, mathematical adder. So we need to include that to use this function. So these are inbuilt functions. Whenever we need to include that, then we have to include with the header files. So area of square is 4. So now we'll come out, we'll use a real-time value. You are able to understand why it is called as real now, no? Since always integers cannot be real values. So real-time value, it should be float. Float means these are all decimal values. Now we will see we are not changing much. I'm just declaring it as a float, while on the right hand side still I'm maintaining a, for initialization, an integer value. Zero. Zero. You see the data is wrong. So the program is compiled, there is no error, while we have error in the output. You have seen, you would have noted that. So when we initialize, we have to initialize with the minute. Yeah. Here mistake is printf, we are declaring it as a again decimal value. So for displaying a float value, here we have to change it to percentage f. Yes. See here 4.000000. So for displaying real, we will be using dollar percentage %d, and for displaying float, we will be using percentage %f. Okay, characters we will be seeing later. So any doubts as of now?
No,
Okay,
I'm good.
okay, and the you are, we have seen that the assignments, that is how the computations are happening here. We have seen that 2.0 from right side, it is assigned to the variable on the left hand side, that is right to left execution within the statement. This is right, and it is executed on the left. Okay, suppose for a I'm just changing this data itself for understanding. Now you see here the computation is happening on the right hand side of the equal to symbol here, that is side into side. And so from the on the right hand side, from side into side, the computation will happen, and then within that statement, and it will be assigned to the left hand side variable. So there are certain sequences uh, within the statement itself. There will be a sequence of operations like our BODMAS rule, where we will be having brackets of definition, division, multiplication, addition, subtractions. So how the computer will be reading it, how the computer will be reading it is, their priority, first priority will be for the multiply and then division, and there is one more symbol, which one more arithmetic operations which will be can also employ is this symbol, modular division. This is modular division, but this can only be an integer value. Modular division can be across only an integer value, while multiply and dividing symbol can be over any character. Even character we can also apply. I usually integer or float it can be operated, while the modulus mod operator can be over only integer. I repeating here. I think you people will knowing that what mod operator will be returning. Let us see here. Let us define the values. Two will take a two variables. One more variable also will take. Will come out of this square program. That is finding the area. Here we'll be defining B, C. We can initialize here itself. 2. We can also do computations here. 2 plus 2, 2. Sorry, I closed that program. Mistake. Okay. That modulation, I'm telling here, modulation is the remainder of a 2 digits after dividing it. That is, if we are having two values, that is, if we are having two values, if I'm using mod operator, then the result will be C is nothing but the remainder of 10 divided by 3, that is 1. That is 10 divided by 3. The remainder after dividing 10 by 3 is indicated as is stored in the as C variable. Okay. So I am requesting you to see the priorities which are in an arithmetic operators, that is star and divider and mod operator will be having higher priority, and then plus and minus will have the next priority, and then is equal to will be having the third priority. That is after computation we are putting on the left hand side. Okay. And there are certain priorities and hierarchy of operations. I request you to refer once before the next session. Okay, we will be closing now. If you have any doubts, you can ask me now. Hello, do you have any doubts?
No doubt, sir.
No, sir.
Thank you. Bye. We'll meet on Monday.
Thank
Thank
you,
you, sir.
sir.
Thank you.
Thank you.